Dear learners, welcome to the topic electron configuration. In this topic, you will be able to learn the followings: description, the orbit and orbitals, shapes of s and p orbitals, the electronic configuration of atoms and ions. Atomic orbit. The stationary shell around the nucleus with the definite quantity of energy is called atomic orbit. This is the first orbit around the nucleus, maximum electrons 2. Second orbit, maximum electron 8. Third orbit, maximum electron 18. Important information about orbit. Stationary shell around the nucleus with the definite quantity of energy denoted by n, where n is equal to 1 to 7. This is two-dimensional, circular. Maximum number of electrons is each shell. First shell 2, second shell 8, third shell 18, and so on. Using the formula 2n square. Energy of different orbit is different. Atomic orbitals. An atomic orbital is defined as the region in space around the nucleus in which the probability of finding the electron is maximum. S, P, D, F, these are the atomic orbitals. In the first orbit, only we have s orbital. The second orbit, s and p. Third orbit, s, p, d, and the fourth orbit, s, p, d, f. Important information about orbitals. Wave function, the region where the probability of finding an electron is maximum, denoted by SPDF. Three-dimensional motion of the electrons. Different shapes. S is spherical, P is dumbbell. Each contain maximum 2 electrons. S2, PX2, PY2, PZ2, DXY2, and so on. In an orbit, the orbitals have equal energy. The shapes of s and p orbitals. S shape is spherical. The three axes is given x, y, z. P orbital is dumbbell shape. I am showing here PZ. Similar way you can express Px and Py. Maximum number of electrons in atomic orbitals. S contains maximum 2, P maximum 6, D10, and F contains maximum 14 electrons. Atomic orbitals we can show using the energy. S1s has the lowest energy, then 2s, 2p, 3s, 3p, 4s, 3d, and 4p. Here the exceptional is 3d. 3d has higher energy than 4s. Aufbau principle. Aufbau principle is needed for the electronic configuration. According to the principle, the electrons fill orbitals starting at the lowest energy first. This is the Aufbau principle. In the first orbit only s orbital, the second only s and p, third s, p, d. So there is no 3f or 2d. So that one, this is the order for the electron entering the orbitals: 1s, 2s, 2p, 3s, 3p. Here there is a break. 4s has lower energy than 3d. You have to remember that one. Electronic configuration. For hydrogen, we have only one electron. It will come in 1s. The first orbit, s orbital, has one electron. This is the explanation. Helium. The first orbit, s orbital, has 2 electrons. For carbon, we have 1s, 2s2, and 2p2 in the second shell. The last shell has s and p, total 4 electrons. For nitrogen, the last is 2s to 2p3. Oxygen, 2p4. Electronic structure showing unpaired electrons in the last shell. If I show here, nitrogen has total 3 electrons in the p orbitals. They have 1, 1, 1, 3, maximum 1p. For oxygen, 2 unpaired is possible. Oxygen has 1 spin pair. Electronic structure from potassium to zinc. Potassium, it is quite easy. 1s, 2s, 2p6, 3s to 3p6 up to this argon is the fixed, then 4s1. For calcium, after argon, 4s2. For scandium, 4s2, then 3d, but I am writing according to the number of orbit, so 3p, 3d, 4s, but actually it will come 4s, then 3d. For titanium, 4s2, 3d, 2, vanadium, 4s2, 3d, 3, chromium, 4s1, 3d5. This is exceptional one. One electron will go to the 3d. Initially it was 3d4, 4s2. So one electron is coming from 4s to 3d. because D half filled, D5 is half filled, this is stable one. Manganese 3D5, 4s2, iron 4s2, 3d6, cobalt 4s2, 3d7, nickel quite easy, copper this is also exceptional. Initially it was 4s2, 3d9, but 3d9 will be 3d10. 3d10 is the stable one, so one electron is coming from 4s. So finally it will be 4s1, 3d10 for the zinc, 4s2, 3d10. Electronic configuration of ions. Electron will be lost from the last shell first. For this one, potassium has 4s1, 4s1 will be lost. For calcium 4s2, scandium 4s and 3d will be lost. For titanium similar. Vanadium, chromium, 3 electrons lost from chromium, 1 from 4s and 2 from 3d. Manganese 4s lost. Iron, cobalt, nickel, copper, zinc 4s lost. It's quite easy. Thank you very much for watching this video.